Hello everyone, this is Liviu Garcia. We'll start in 3 minutes.
Hi, this is Alex. We're looking forward to this webinar. Liviu, just doing the sound check.
Yeah,
I hear everyone. Hi guys.
Hello. So we'll start in 1 minute.
Hey Luca, welcome.
Glad to be back. Sorry for the inconveniences.
Don't worry, all good. We're all here. By the way, I had the same issue as you, so I'm also connected via phone.
It seems that this is not the worst thing that can happen. I'm glad it works.
Of course.
Good. So hello everyone. Good morning. This is Liviu Garcia from, I'm a managing partner and at btProvider. And this session is dedicated for data, for big data, for large volumes of data, and the way we manage it and we work with such data. In terms of agenda, we'll be having a short introduction, speaking about who we are, what we do, what are our activities in the region. Then we'll speak about data science or the super data science in Superbet, one of the companies that is managing in a very scientific way large amounts of data. Then in the third part, we'll be having one of the Vertica, most well-known Vertica data scientists speaking about predictions in football games. And we have a set of questions, some time dedicated for questions and answers in the end. In terms of the speakers that we are having today, from the left side, the pilot Badr Wali, the head of data science at Vertica, the VP of data in Superbet Group, Luca Postrutin, and Alexandru Savencu and myself from btProvider. A little bit of a short introduction of who we are and what we do. We do the technology part in terms of reselling the technology that we are working with on the local and the regional market. We do the implementation, the consultancy part, the analytics, the strategy, education, and we take care of the community. In terms of business lines, we have two business lines. One is related to data analytics, the main business line. We have a series of partners here that we are working with. I'm speaking about Vertica, is the technology, the analytics, the engine that we are using in all our implementations in order to produce value insights out of the data. In terms of data project, we cover all the main phases of any data project, since a bit is born within an operational system until that bit is producing value insights or information in front of the end user. So we do the collection of data from different systems, online, offline, SaaS or non-SaaS systems. We do the storage and the processing of this data, the analysis and the visualization of this data from different or any kind of data source. So Vertica is the main engine where we store, we process, and we analyze the data. Tableau is for visualization and Talent for ingestion. The second line of business is the digital processes, relying mostly on Salesforce technology. In terms of data analytics, there is plenty of words related to this topic, starting from big data, from data visualization, data discovery, the business intelligence, traditional BI, data warehousing or modern data warehousing, descriptive or predictive, artificial intelligence, machine learning. Everything you see on the screen, and probably more words like that, are relying on one very important layer, is the data layer. The way we store and process the data is extremely important, because as per our experience with different organizations, even if 10 years ago the volumes of data was increasing at a very fast pacing, I think that today in November 2020, it's not a very fast pacing, it's an overwhelming pacing. We see organizations flooded with data from all kinds of data sources, online, offline, from all the digital marketing channels, from all the consumer data channels. So really a lot of and very high and diversity volumes of data. In this context, having a powerful engine that can store and process that data, it's absolutely a very critical part of any project. In order to support the current needs, but more important, the future needs, because the pacing of data multiplication is increasing. A little bit about the technology that we are using. In simple words, it's the columnar storage that Vertica as a big data solution has, that is speeding up the time reading the necessary data from the database, becomes an extremely important scenario, because we see more and more organizations moving from the traditional reporting to a data exploration scenarios. And data exploration means, like, literally the Wild West. You have basically have users querying data in the database from different tables, sources, joins, unions, and so on and so forth. Compression, which is lowering the cost due to a lower footprint on the machines. We've seen compression ratios of probably 1 to 3 or even 1 to 10, depending on specific use cases and type of data. Massive parallel processing scale out, where basically provides a high availability and high scalability on different clusters, different nodes, and the distributed query. Every query is executed on multiple nodes. There is no single point of failure, because every node, Vertica node in the infrastructure, is failing. The other nodes are automatically taking over, which is also reducing the administration effort and is increasing the availability. Projections, it's a query optimization performance mechanism that is pre-preparing the data for analytics. All in all, Vertica, it's one of these solutions supporting large amounts of data, simplifying the overall architecture, so no need for HDFS. You can still use that and put Vertica on top of it, but basically it's a very simplified architecture. You collect the data from different systems using traditional ETLs or even data streaming solutions like Kafka. You put the data transformed or raw data into Vertica, and then with other solutions, visualization or other querying solution, you query data from the Vertica using the columnar, the compression, the MPP scale out, the distributed query, and the projection, increasing the fast pacing of processing and analyzing the data. A little bit of machine learning processing, so a lot of algorithms inside the machine that can be used, like linear regressions, like native Bayes or time series, geospatial functions and analysis. I'll leave Badr in the last part of the session to speak more about it and make a demo of how we can use that directly in the technology. But Vertica is on one side a very fast data analytics engine where you can query data using pure ANSI SQL queries, and on the other part is also machine learning and data science tool, because you have a lot of functions, of statistical functions, algorithms, machine learnings inside the box, ready to be used. And this can also be extending using R and Python functions. So Badr will speak more about this part. Then in terms of deployment, Vertica, it's a vendor agnostic solution. It can be deployed in different clouds, from Amazon Web Services, Azure, Google, VMware, so most of the well-known clouds. It can be installed on-premise, and it can be deployed over Apache Hadoop in order to take advantage of the Hadoop data existing in org files, Parquet, and more. So it can be cloud, it can be on-premise. Nodes can be deployed very easy in order to support scalability. And in terms of volumes, we've seen customers having tens of tera of data, hundreds of tera of data. And we have also seen in this world customers having in Vertica petabytes of data that is queried and processed. So it literally can scale up to hundreds of tera or petabytes of data, which is the case of today's use cases in the world. Having that said, this short introduction, I'll pass the microphone to Luca, head of data in Superbet, to speak about use cases, the way they use data, and how much fun they have working with such technology. Luca, can you hear us?
Yeah, all is good. Do you hear me?
Yes, we can hear you. Let me pass you the presentation mode. And now you should be able to share your screen.
Just give me a second.
Should be on the top side of the screen.
Yes, it requests some privileges. Which might be. Do you see my screen now?
No, not yet.
Not yet.
Let me make you organizer. Probably that will extend the.
Potentially, it's a challenge. Is there a way that you show the screen? I think it will be easier at this point.
Okay.
I think it's a problem of privileges with the laptop currently, which I didn't add before, and it requires a restart. So I think that would not be the best solution.
Yeah, sure. Let me share the presentation. Hold on a second. Just a couple of things.
Okay, so basically as an introduction, the main goal for today for me is to show you a bit what actually data science within Superbet means, and also to explain you a bit why we chose Vertica as a platform and what we can actually do with it. The use cases that we had in the past year and a half that I'm here, but we are using Vertica for more than 3 years now, for various use cases, took us to the situation where we now have real-time data streaming in parallel to, let's say, broad variety of different usage scenarios that we are using. Great. You can move on to the next screen. So basically, on the agenda for today, just to break some myths on Superbet. I worked in telco and banking company before, so usual myths always exist, and this is for betting as well. To take you through the modeling use cases that we are having, and then to explain you actually how we are doing it from technical and organizational perspective. So moving to the first part of actually why Superbet and why Superbet is here, and what we are doing. So basically, great. So betting companies, as you will see in Mother's presentation, like we are also fetching a lot of data within our betting platform to provide our users best experience and with the best offer on the market. What this actually means that on, for example, a football match, every corner, every chance, every card, every situation that happens every second, our betting platform, which is in the center of our, let's say, ecosystem, uses it in order to produce correct probabilities for the customers to place bets on. And basically what we are doing, we are collecting a lot of outputs from that system. I've put here only 4 examples. So basically, for the wallet transactions for online betting, solely in Romania, we have roughly 30 million records a day. For sports betting, we have 1 million tickets received, and basically on ticket row levels, we have 70 million changes, and basically on the offer, 60 million. So this is just a, let's say, high-level overview of the amount of data that we are having, which brings us to 5 billion rows inserted and processed on a monthly basis. And this is without like 95% of other data sources that we are ingesting. How do we actually do it, and what do we do? We ingest this to Vertica. So we basically have micro batches, which are going currently on every 2 to 3 minutes for every Kafka topic that we are consuming. And we are putting the data into Vertica and using it immediately. So one of the use cases that we had very recently, we wanted to have some, let's call it operative reports going out using the also Tableau in front, which combines extract data every 5 minutes or 15, and using the delta with the live queries to get to the most recent data for the reporting purposes. So to answer and to break the first myth, why betting and gambling actually has to do with data, we have a bunch of data that we want to use. And basically we have one problem which usual, let's say, enterprises are also facing now, but we are, let's say, breaking it a bit earlier. And this is the real-time component. So we actually want to have near real-time reporting available for the whole company. Moving on to the use cases. Basically today, data science topic. Again, what does it have to do with betting and gaming? So basically, as in any other market, as in any other industry, we have a lot of customer experience things that we want to enable. I'm not sure how many of you know about Superbet history, but we are growing rapidly. And let's say that our goal is to overtake the world ambitiously, but we are slowly progressing towards expanding on other markets, and we want to have the best product for betting and gaming that is currently available. With that being said, we need to do a lot of things on our end to enable best customer experience. In order to do so, we are doing a lot of prediction models for seeing actually who is a VIP customer, who is not, to see who is actually the potential churner, to analyze our products, to basically do various reporting parts to enable product organization, to know what to do next and actually which feature to develop next. But also we are utilizing it to make personalization algorithms. So basically all of this data resides in Vertica, and we are using it as, let's say, our core analytical platform, which enables us very fast queries, and it enables us near real-time data availability. We evaluated several other databases in between, and in order to enable broader range of users of using and utilizing data, it provided the best results for one, let's say, very obvious but very important reason, and this is query performance. In the past, we had, for example, AWS Redshift and also some other databases on the platform itself, but no other database actually provided such good query performance for a broad range of users. Basically, to answer you how we are doing this, the architectural standpoint that we have everything hosted on AWS at the moment regarding analytics. And there are a couple of components here that I would like to mention. So in the center of things is, of course, the database, which actually consumes the data from the real-time streams using Python. We are using regular ETL flows with Talend and Pentaho, where we actually manipulate the data and provide it into some common layer, which is then consumed by management reports or some other use cases that we have. In front of the Vertica, we have Tableau, using it for analysis, but also for standard reporting. In the past year, we scaled from, I think, 15 to 250 users in the company. And we are combining data extracts, and also we are combining it with the live queries going to the database to get the most recent data out. The important thing to mention here is that, let's say, this scalability that we achieved with this stack actually came without a high toll price of implementing such a complex system, because basically stuff works in majority of the time. In the past year, we upgraded Vertica hardware once because we were basically on a, I would say, child hardware for more than 2.5 years. And now things look very, very good on our end. One thing that when I came to the company, which I heard very often, was given by the power of Vertica, we are doing it like this. And this enabled us, as I mentioned before, a broad range of analysts querying the database, getting the responses without actually having an issue on the ETL part or on the database performance side. So the architecture is one point how we enable this. For the data science part, we are actually using data models in R and Python. We still didn't embark on a journey of putting those codes directly into Vertica, so we are basically utilizing Vertica's engine to query the data, to prepare it, to clean it, and to digest it. And the pure model is executed then in R or Python side, but we are moving towards this direction to try it out, and most likely this will be on our roadmap for the next year. Main reason why is because we were piloting the Python functions. They're proving to work rather fine now. We are using them in the ETL because they enable you to write whichever function you want with the data. And we find it useful for some data transformations. But our data science team is growing. We will now do more consolidation in that area. And one of the ways how we will try to optimize the flows is by utilizing Vertica's engine inside. Moving to the second enabler for this, this is less Vertica related, but much more data science related, is how actually within the organization we have a setup that enables us to get the data. Basically, the boxes here, let's call them boxes, are teams within the company that are working to assure that we have stable systems, stable data, that we collect the data and enable it for various use cases, and to have people within the company who are actually utilizing it to provide better, let's say, results for our stakeholders in the board. First use case that I would mention is combining data science team and the traders. And what we did basically based on the first place in-play bet, so during the live match phase, we are trying to detect whether a customer is good or bad for us. Good or bad doesn't mean that it will take us money, but it means that we have some potential frauders that try to exploit some issues on the system or on the feed providers that we are using. And we are trying to predict it based on the solely first bet. So what we needed to do is to find let's say, a department which will be interested in using it. These were traders, and we worked together within a small micro team for a project of a couple of months, where we enabled this use case to go live, mainly using Vertica's engine as a data, let's say, standpoint, but also we are putting the results back to Vertica and showing it in Tableau, and potentially we will integrate it in the core platform for traders. Second most important part is that the data, let's say, part of the company, but also the data culture comes from the center. We have several teams working on this. Some of them are currently in the making, some of them are working, and we have a strong BI team which works for quite some time now, producing a lot of reports. So the last one that came out in cooperation with business technology provider company was the monthly summary, which looks in a way that I haven't seen something similar in all of my past experiences and with everybody who I work with. This is basically enabled by two things that we have, and this is Vertica and Tableau. Moving forward, basically what we see and expect that will happen, we currently have 20 people in those yellow parts. End of this year, we expect to be on 30. We are already in some hiring processes. So at the end of 2021, we expect that we will be most likely on 40 plus. Main reason why is because we want to have internal knowledge for most of the things that are important for bringing value. And we have a lot of use cases on the plate. This one, who wants to join, is basically a question for both engineering, for data. We have quite a few openings, and the job actually that is offered is quite interesting and intense. Key takeaways for today, which I would like to mention, and I think that are rather important. Real-time data definitely becoming a thing, and it's a possibility. Vertica enables this with basically no huge investment in hardware, and everything works. Projections are a very fun thing that really enables utilization of this. There are some solutions on the market that enable just real-time reporting, but I would say that with Vertica, we have a broader range of use cases that we can execute. Cloud ready is a plus, as we saw before. One minor drawback, that there is no software as a service and platform as a service mode at this stage. Hopefully it will come. Query performance, as I mentioned, definitely the key. If you don't know what to do, contact btProvider. And data science and modeling, definitely easier when data is prepared on a platform which actually executes the queries in a fast manner. Cool. With that being said, the only thing that I want to enlighten is that Superbet is always hiring. Reach out. And as a last point, I definitely want to thank btProvider as helping us on this journey. If someone here is trying to find a potential suitable company to work with in the following period and to enable you on the digital journey, I think you cannot actually miss with them. We have been in cooperation for some years now, and I'm certain that we will stay in this position for the future as well. This is in short for me today. If anybody has any questions regarding anything that we have seen, feel free to reach out. Emails on LinkedIn, everything works. And thanks for listening.
Okay, super. Thank you very much, Luca. Yeah, Alex, you wanted to add something to this conversation? Okay. So thank you again, Luca, for the presentation and for the insights and the details. Definitely, as you have seen, a very innovative environment in terms of data and analytics and data engineering, and all the space that data comes in. Next part of the presentation, we'll see how this technology really works in data science. We'll have some hands-on experience with Badr Wali. He's the head of data science in Vertica. Badr, can you hear us?
Of course, Livio, I can hear you. Thank you, Luca, for this very interesting presentation. So I will just share my screen, and then we can start. So let's go directly through what is Vertica in terms of machine learning. It's very, very important to define what the out of the box of Vertica, the possibilities we can do with an advanced analytical platform. And during the last presentation, we saw this power. We saw the traction around Vertica in terms of features, in terms of data preparation. And you can see all these components together that makes this database more than a data warehouse, typically a database made for analytics. And the machine learning of Vertica is built into its core, which means that these algorithms are built from scratch in C++ in order to be fast and scalable. And everything, so when we say built from scratch, it means that we didn't use any third-party tools in order to compute as back-end ML. We are using our own ML in order to be fast and scalable. And we can see here a quick example. We can see, for example, a random forest, and we can see that each tree will be learned in different nodes, and much more, because if we go deep into these models, we will see that each split can be learned by different node, which makes it fast and scalable. In Vertica, you can follow the entire data science process without moving the data out of the database, which means that we can ingest using different types of format. We have what we call the flex tables in order to, for example, ingest CSV, JSON, and even more, because in Vertica, you can even do geospatial. If you have geospatial data, you can ingest your shapefile and play with it, which makes it quite complete, because right there, you can use any types of data you want. You can ingest it, and then you can measure it, and we will see it through the example. You have many functions in order to get some statistical summary, for example, or to play with time series, which means that just imagine you have a time series, you want to slice it, you want to interpolate, you want to fill the gap. You have functions both in SQL and Python in order to do it. And I will show you some of them just in the next slides and during the presentations. Of course, many functions to prepare the data. You have access to all the standard SQL, and of course, increased number of functionalities, which means that you have access to built-in functions in order to, for example, to detect outliers, to normalize the data, to impute the missing values, to encode the data. For example, you can create a one-hot encoder model and then one-hot encode your data in order to get, for example, your dummies. And then you can go through the model training, where you have access to different types of model. During the presentation, we will see the random forest and the k-means, but you can see all the models in the documentation. You have much more. Our policy is clear. If the model can scale, if it is scalable, so which means that if we can if we can code an implementation that could scale, it will probably be in the roadmap if it is not coded now. So typically, we are trying to provide you all the possibilities in order to get performance, in order to have fast results. We want to speak with the data, to have this conversation in order to understand exactly what we have, what can we do with our data. Of course, last step, evaluate the model. You have rock curve, leaf table, and other functions. And to deploy, you have in Vertica an entire model management system, which means that you can play with models the same way you're playing with tables. You can select them, look at the coefficient, look when they were created, and export it. This is the multiple ways you can solve your data science challenges in Vertica. So the SQL front end, it's the native way, so you can do everything in SQL, a lot of built-in functions. We emphasize, we created this Python interface in order to make it more flexible, and we will see around this Python interface in the next slide. But you can also create your own user-defined functions, which means that, for example, if you build a model from outside, you can bring it in Vertica in order to do the scoring using, for example, user-defined functions that can be coded in R, Python, C++, or Java. Quite new in Vertica, you can bring also your TensorFlow model, which means you can bring your frozen graph in order to do the scoring, not the training, of course. You will train in a TensorFlow cluster, and you can import, export using PMML. We have also integration with other tools in order to do the scoring directly in database. which makes it very open to other environments and can really help you in order to win a lot of time in the process. So as I said, let's now speak about the combination between Vertica and Python, which is the Python integration. Now, Vertica offers you a Python front end with a lot of functions, with an object that will be very similar in terms of use to Pandas scikit-learn, but will push all the heavy computation to Vertica, which means Vertica Py is Python front end. You will have this object. You push the aggregation directly to Vertica, which makes it SQL backend. So you gain all the performance of the platform. But as you are using Python, you can get some rendering capabilities. So you can draw graphics, do more data exploration, and makes it an entire data science lab with few lines of Python. You can generate many lines of SQL in order to follow the entire data science cycle. This is a bit the architecture of Vertica Py. You can see that you have access to different objects, the virtual data frame and some ML objects that will push the aggregation to Vertica using any types of connection you want. So you have ODBC, JDBC, or the native connection, which is called Vertica Python. Vertica will compute all the aggregation, send back the result, and then you can use the object to do data exploration, to do your data preparation, and of course to build your model, to evaluate your model in order to then put it easily in productions. You will have many benefits because we have a very good integration with Jupyter, where you can draw a fantastic graphic, and you can play the same way you're playing with over Python technologies, but this time you're pushing this aggregation to Vertica, which means that you get all the terms of performance and you don't have to load data in memory. So this is a quick example for you. You can create a virtual data frame this way. Here I'm using a DSN in order to create my connection, but you can put as input a cursor, for example, a connection to the environment using the type of connection you want. Then this object, for example, if you run describe, will send a SQL query to Vertica. We can see some built-in functions like summarize new column. That is like an extended functionalities built in order to be faster than writing, for example, a select, sum, average, quantize, etc., which can be very heavy in terms of computation, writing many elements. So here we extended the possibilities in order for you to be more performant and to write simpler query. So here, .describe, generate the correct SQL statement. Vertica compute the aggregation, compute the result, send it back, and then you get the output. So now that you know the process, let's switch to the demo and let's go through the football demo. And this use case will show you how Vertica Py is working and how Vertica is working and the different functionalities, of course, that are available in Vertica. During this use case, we will use some very simple data because we already know that in order to be more accurate, to do some better predictions, we need more than the data that I'm showing. We need, of course, to get, for example, which players are playing for these games. For example, if you have Barcelona, is Messi playing this game, for example? Or this type of information, is he in good shape? What was his shape in the last games? If you increase the possibility, if you increase the data set you're using, of course, you will have better prediction. But you will see that we will do not so bad prediction using only this data. So we have the result of the home team, its score, the same for the away team, the type of tournament, very important because of course you're not playing the same way when you're playing a friendly game or rather than a World Cup where the tactics are totally different, which means that you will not play exactly the same way. The city where the game took place, the country, and if it is a neutral location or not. So in this case, home team and away team that doesn't really make sense, which means that the two teams are in a very different environment. So we create our virtual data frame, and you can see that I'm using the table public football that is located in the Vertica database, and we can see a little bit the head of the data, what it looks like. Of course, a home score, away score, the different team, the date. The date will be very, very important because we are dealing with time series. And with time series data, we must take this timeline. We cannot, for example, use data of the future to predict the data of the past. We really need to have a correct strategy when dealing with time series, and we will see how. To show you what's going on behind the scene, let's compute a describe. You have the possibility to turn the SQL on, and we can see that I'm sending to Vertica right now a summarize num column, which is an extended built-in functionalities. But I want also to get, for example, the cardinality of each element. And for this, I need to just compute some count distinct of the different columns. And you can see right there at the end my little array, my summarized statistics. Of course, the same. I want to compute a correlation matrix. You can see that I will send a select core matrix, because just imagine with regular SQL, what I have to do is to send a select core feature 1, feature 2, feature 1, feature 3, etc., which doesn't make really sense, because just imagine that you have 100 features, then it will send 10,000 aggregations, and then you can see what could happen in terms of performance. Rather, when you extend the possibility, you create some customized functions like this type of built-in functions, the process will be much more faster. And then you get, of course, your correlation matrix. I can turn this functionality off, and we can just go through data set in order to understand what we can do. First, let's describe the date. We have the football games going from 1872 to 2020. Okay, to really recent football games. What we could do, we know the last World Cup was won by France. And of course, as you can hear with my accent, I'm French. So what I will try to do is to predict if France will win the last World Cup by using all the data that are previous to the World Cup. And that's what I will do. And after, yeah, and if you have any questions, of course, you can send them to a chat or send a mail or connect to LinkedIn. And then you can ask me if you want to know the result, for example, of the next Euro or the next World Cup. It can be very funny. So right there, we can describe the data set. We can see the different games. You have, for example, friendly tournament that are the main type of tournament, which makes sense because you are playing more friendly games rather than competition. But here you have, for example, qualification to World Cup, qualification to Euro, and the games to World Cup that are really low to the other types of games. You can see that, for example, the qualifications, you have much more games for the qualification than the Cup itself, which makes also sense. So we will need to use all this information in order to do our prediction, and I will tell you the strategy, what we will do during the study step by step. So first, we describe. We can look at the statistics. Quickly, we can understand that the home score is higher in average than the away score and higher than 0.5 points, which is a lot. So we can, after compute some confidence interval that we will not do there, but we can understand that being at home makes a little bit the difference during a lot of games. So then, what we can do, we can just compute, for example, here some over aggregations. We can look at the different, for example, which is the team where we have most of the games. We can see at home that we have more games from Brazil. We know the quality of Brazil in terms of football. They won a lot of competitions. They are quite good. And Uruguay. And we can continue to investigate, but as we saw with Superbet, what Luca told us. He told us that he did a lot of data preparation in Vertica. He was, for example, building the model outside to bring in it, but he was doing a lot of data preparation in Vertica. Why? Because you want to do all this data preparation close to the database, because that's one the most important part. And we can see that during time, for example, some team change their name, which means that we have to have the exact same name, because if we don't have the exact same name, the machine will not understand. They will think, the machine will think that we have different categories, which doesn't make sense. So for example, we can Germany R, that is Germany or over teams. And then of course we have some teams that didn't play a lot of games. They played 5 games during a specific competition 30 years ago. We cannot consider them in the dataset. It's totally useless. So I can use direct aggregation right there in order to filter the data and to consider only the team that played more than 5 games. And what we will do first, we will compute some clusters. We will find some rank for the football teams. Why we are finding ranks for the football teams? Let's say we want to create hats like the same way in World Cup. When you have, for example, the different group of teams, what's happening? You take, the FIFA is taking one very powerful team that manage different competition, then a team that is good, then a team that is an outsider. And how do? They create some kind of hat, and then they pick randomly the team. So we will try to create these clusters in order to make our prediction better. For this study, as I said, I want to predict, for example, what happened during the World Cup. So what I will do, I will take data from the past, till the previous World Cup, in order to understand how the team are playing, in order to build our clusters. And how I get, for example, the number of cup per team? Quite easy. What I will do, I will use a row number, which means I will order the data by date, descending, and by tournament and year, which means that I will look at the last game of the tournament in order to know who is the winner and to increment the number of cup he has. And that's what I will do with all the team to get the winners of all the competition. Of course, in this data, there is, I don't know which team is the winner in case of draw at the last game, because I don't have the penalty. I don't have the result of the penalty. And that's why, you know, when you're doing, when you're playing with data science, you need to also take data out. For example, this data is missing, then I try to figure out how I can ingest this information and play with it. In this one, we will have an approximate number of competition per team. So let's play with it. For example, I will compute, for example, some aggregation and compute my table, and you can see, for example, the winner, the number of World Cup and Continental Cup, but it's approximate. It can, for example, we can be wrong for 1-2 competitions, because if they did a draw in the last games, then they are not considered. But we have a pretty good table. It gives us a lot of information. The best team for World Cup, for example, and Continental Cup are the Brazil, of course, with 4. Normally, I think there are 5 World Cup, but here 4, and 8, for example, international competitions. But we have a pretty good array in order to do our clustering. But what we need after, we need, for example, the team configuration. The team confederation can be good in order to understand the team quality, which means that playing in Europe or playing in South America is not the same as playing in Asia, Africa, and less in Oceania, which means that the confederation can have an impact. To get the confederation, we can play with the data and say, okay, if you played a Euro game, it means you're probably a European team. The same for Africa, the same for Asia, and then of course we will, if we have Copa America, and for last result, we will put overs for Oceania and over teams that didn't play like international competition or play just friendly game. But we should have filter at the beginning. I think it could be better. And then we have a confederation for each team, and we can just decode it quite easily to get the confederation. We can save as a table this result, these functions. We are playing with a virtual data frame, which means that we are playing we are playing with views, for example. So here we are just pushing some SQL query, and when I save it, I create a new table. Now I want to compute some KPI, but just imagine that home team is so of course team are playing away and at home, so they can appear in two columns, the columns away team and the column home team. So what we need to do to compute statistics, to compute the number of victory, we need to duplicate the data set and to switch the two elements in order to for each team to play to have all the games in one column. And we don't care about home or away. We can create, for example, a little dummies or like a feature 0 away, 1 home, and 2 neutral, for example. And then we can just compute our aggregation, compute, for example, the number of World Cup, compute a lot of KPIs, the number of victory in each competitions, and we can see here, for example, all the KPI we can create. Of course, I'm using some average, some sum, the number of competitions, etc., etc. Of course, we will see after that we can use also some moving windows. So let's create because we will use also some visualization. And what I will do also, I will normalize the data. Why I will normalize the data using min-max? Because it's very important to get data at the same scale, at the same range, in order to use a k-means clustering. So what I will do, use min-max, and you can see all my statistics right there between 0 and 1, all my KPI in order to build my clustering. We can see also that we have some missing values, but this missing value makes sense, which means that if you have missing value in the number of continental competition, it means that you don't have any continental competition. So we can fill all the missing value by 0. They are missing not at random, which means that we know the sense of the missing values. And when we clean it, we can export this football table. In order to pick up the correct number of clusters for the k-means, I will use what we call an elbow curve. So the elbow curve will help us to identify a suitable number of clusters to build our what we called previously our hats. So here I will build elbow curve with 2, 4, 6, 8 clusters. We can see that 6 could be a possible good number of clusters because after the error is not decreasing too much. So we can see it in our elbow curve. So let's build some clusters, and what I will use in database machine learning, the in database k-means of Vertica right there with 6 clusters, but I will put my clusters by hand in order to have, for example, a rank that is linear. What I will do, I will put, for example, the cluster 0 with very bad team, the one that are not winning a lot, whereas I will put a cluster for the champions in order to converge where the champions are, because if I put it randomly, I will have some random cluster. So then I can add my predictions in my virtual data frame, and we can see, for example, the rank. We can see that the best team are there in this hat: Uruguay, Spain, Italy, Germany, France, and Brazil, Argentina. And what we can do right here, of course, we can look at the worst hat, and we can see some teams that are not really playing a lot of games, like for example Zanzibar or the Tibet that have not let's say a very good football team. What we can do, we can compute some bubble plot in order to look at our predictions, and we can see clearly that the Brazil is at the top, followed by some other teams from Europe, because Europe are very, very, very good at football with South America. We can see it right there. We can see the worst team right there. We can see, for example, teams that are winning a lot of international competitions, but they are not going to world competition. What makes a good team? A good team will be very good in decisive moment, which means that they will win international competitions, and they will go very far to world competitions. We can see here our bubble with the rank. We can see that the higher rank are there. Then you followed in yellow by the second best rank, and we can see here, for example, that one of the team of had 2 that is not very good did it once in the World Cup. Of course, we can draw some box plot. Everything is pushed to Vertica. Vertica is computing the aggregation, sending back the result, which makes it very scalable. And then, of course, we can export the result. And then last step will be to do our predictions in order to play with it. So now what I will do, I will switch as previously the team in order to have for one column the same team, even if it played at home and away, but I will add a flag 0, 1, 2 if it is neutral away or at home. I will add all the KPI I computed previously, which are KPI for the many years before. But what I should do, because what will influence most of the game will be to add moving windows. What I need to do is to add, for example, the average number of victory in the 10 previous game, the number of direct confrontation with team 2, the number of games won with, for example, one of the cluster we created. We need to create a lot of moving window. Look at the 10 previous game, the 3 previous game, the 5 previous games to look at the shape of a team, and I will create many different features. As you can see, I'm executing on my notebook. I'm just creating many different moving windows in order to do my predictions, and after I can look at the one that are the most valuable, of course. Then what I can do, I can prepare my data when I computed all this moving window. I have to clean some of the missing values, so that is what I will do. I will clean some of my missing values depending on the type of missing values, and I can save my data set into a table in order to compute my random forest classifier that you can see right there. What I will do here, as we don't really have time for it in the demo to compute a huge number of estimator, what I will do typically, I will use just 5 estimators. Because normally you should use more estimators in order to have a better score, in order to generalize better using this random forest. And of course, you need to do some parameters tuning in order to get a better predictions. And then we can look at the accuracy, the score. Of course, now we can compute, for example, the score of the model, and do some predictions. So I will execute this as we are in the end of the presentations. And then here, as you can see, I'm just importing the random forest classifier of Vertica, and then I create a random forest with 15 max depth, with only 5 estimators, and with many leaf nodes in order to get the games. And you can see one of the parameters, which is mean samples leaf, which means that per leaf, how many games I should consider in order to say that this prediction is valuable. Because if I have only 1 game, I cannot generalize. We say that if I have 3 games at least that are similar, so in this case, I can consider, of course, the predictions. And we can see right there that depending on what we consider as positive category, we have predictions when we are more at home than away, and we don't predict very well the draw games. But we have 55% of accuracy right there, which is not bad at all, because do not remember that we are dealing with a multi-class classification, which means that being better than 33%, and we are, like, let's say, almost doubling the random prediction, which makes this model quite good for the predictions. Then we can look at the features importance. We can see that the average number of victory for each rank is very, very, very important. and of course do the predictions for the World Cup. As you can see right there, I'm computing my predictions in order to say which team will win. And let's play a bit right there. Let's go through the World Cup. France, Australia, for example. France with 70% of chance of winning. France won, of course. France against Peru. France will win with 60%. France won. France against Denmark. Our model said France will win, whereas it was a draw, but France won after the penalties, I think. France against Argentina. France will win, but it's more with a less prediction than the other, but 45%, which is a lot in this type of games. Then France, Uruguay. Our model said that the Uruguay will win and France won, which means that our model predicted that France would go till the quarter of the final, which is not bad. Then France, Belgium, our model said France will win. France, Croatia, it said France will win. Do not forget that this model will learn step by step even the last games. For example, there is this moving window, so it's looking at the last game and it understood that France won Uruguay, which means that the probability increased. And so thank you very much for attending to this little demo. We switch to Q&A, and thanks to btProvider for organizing this event, and to Superbet for this very, very interesting use case.
Okay. Thank you, Badr, for this interesting hands-on exercise where we see how we use all the algorithms. We have one question. We are 4 minutes after the end of the session, so we'll take one question. Maybe you can take this one, Badr. Can you store and reuse the clustering results? How can you access the results of the clustering mechanism? Is that possible in Vertica?
Yes, of course it is possible. You can have access to a lot of information about your clustering algorithm, both way in Python or SQL, which means that typically you have SQL functions in order to get the attributes of the models, and you can export it. For example, if you want to export it from Vertica to another environment, there is the PMML side, but everything is stored and you have all the information.
Okay, super. Thank you very much. I think we came to the end of the session. I'd like to thank very much Luca from Superbet and Badr from Vertica for joining us in this session. I'd also like to thank the attendees. We've seen a lot of attendees today for different industries, which means that data and large volumes of data is not linked to a particular industry. So volumes of data are increasing everywhere. So thank you all the attendees and the speakers. If you still have questions and you want to go into more and much more details, and as you can see, we can go into a lot of details in this topic, you can contact us directly. You have our details on the screen, and of course you can connect to any of the speakers we had today and ask them directly your questions. Thank you very much. Enjoy the rest of the day.